Hello everyone, welcome back to Stat385 for another video. So in this video we are going to go into a deeper dive into factors. Okay, let me zoom in just a little bit. Okay. Did I? Okay, I'm gonna clear all this. All right, so first of all, let's go back to the beginning. We've covered factors a little bit before, so some of this will be a little bit of review to start out. So like, let's say I have a character vector corresponding to the question, what is your favorite pet? And let's just say it looks something like this. I know that it's gonna be pretty wild if to think that you would ask 6 people. Actually, more specifically, let's say, do you prefer cat or dog? And I know it's pretty wild to think that if you were to even ask that question, with those specifics, that you would get a vector with 3 dogs followed by 3 cats, but you know, whatever, this is just a demonstration. So this is going to be a character vector. Here it is. We can see that it is in fact character. Okay, so we've seen this before, and I could, since it's a vector or a character vector, I could take one of the elements out and reassign it. So take the first element, and let's say somebody said zebra. And you know, if this were to actually correspond to the question, what's your favorite pet, cat or dog, then zebra is not really an allowable value, but you know, R doesn't care because this is just a valid thing that you can do. Okay, so that is potentially problematic if we're going to use this vector downstream in some analysis, and if you're going to, you know, just work with it. Okay, so let's put dog back. So now let's try this again. Pets equals factor. Let's just copy this character vector in. Okay, so it's going to create a factor with 2 levels, and it's going to read and find these levels from the elements of this character vector. And we could actually manually specify them, which we'll get into in a little bit. Okay, so now I have a factor variable. The display is similar but slightly different. Notice here that we do display the values dog, 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 cat, 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 but then there's also this levels corresponding to cat and dog. This becomes important because if I want to, and I can actually show the levels of the name cat and dog. Okay, so now if I try to do my thing above where I replace one of the elements, reassign it the name zebra, then this structure in the factor variable, where with known set levels, is going to complain about this. So I get a warning message. Value zebra, and that is an invalid factor level, and an NA is generated. So you can do it, but it's not going to allow you to. Well, you can do this, and it will run and do something, but it's not going to actually allow you to input in the value zebra here. Okay, it's an invalid level, does not exist. So they're not going to record it. So it's just going to get tossed aside as an NA value. Okay, let's put dog back. Okay, so pets, there we go. Okay, alternatively, I could do something like this, and let's say I wanted to ask people a question. What's your favorite level cats, or sorry, what's your favorite pet, cat, dog, or bird? Then you could get a vector with 6 responses and not observe one of the levels, but it could still exist. In that case, you may want to input it as a factor, but specify the levels directly. And so here we have pets, it's the same thing. We get the same output as far as what's displayed in this vector, but you can see here that level's bird. Okay, cool. So if I were to now do pets 1 equals bird, then I'm not going to get a complaint here. It's one of the acceptable levels. If I do pets 1 equals zebra, I get complaints again. Yeah, makes sense. It's still not a level. So let's just put bird back. Okay. Okay, good. Okay, so a little bit more detail on factors than we covered earlier in the class, and we'll go back to a little bit of review again. We can see that things get really confusing when we investigate the attributes of what a factor is. So, is a factor a factor? True. Is a factor, an integer? False. However, if we look at the structure of this factor, it says it's a factor with 3 levels. It gives the levels, and it gives an integer representation. If I were to do as.integer, it's going to pull out that integer representation. Fine. And if I go and investigate the actual type of this vector, it's integer. So this is really confusing. Okay, so let's read some documentation. Is.integer. So what's going on here? Value. So is.integer returns true or false depending on whether its argument is of integer type or not. So it is of integer type, but then it says unless it is a factor, then it returns false. It should be the head. Unless it's a factor, then it returns false. Okay, so there is an integer encoding under this. This is a type integer vector. The display is these categorical levels: dog, bird, cat, but there is an integer encoding. And I think the reason for this would be that if you were to do some sort of downstream data analysis, or a regression type problem or whatever, and these are categorical levels, meaning something in some analysis, you're not going to be able to do, say, like a least squares estimate with something in a matrix with dog, cat, bird. So there is an actual integer representation. So when you actually do, linear algebra to get least squares estimates, you actually have something that works numerically. So this kind of is this, I should be precise. It's not mixed type, but it has this like mixed type flavor to it. It is a type integer vector, but the display is categorical, and it has these rules that we investigated, namely that we have particular levels, and this vector can only take values that correspond to these levels. These levels each have an integer encoding, so that this thing corresponds to an integer representation under the hood. This gets into a little bit about, in the background is this, the S3 system with like what is being printed here in the structure of what this factor is. So we have a factor, it's an integer vector, and has a categorical display. And so we've seen stuff like this before. Okay. All right, so now let's load in the tidyverse and discuss factors in a little bit more detail, namely this for-cats package. Give me 1 second here because I am going to I don't have my website updated yet, but when it's updated, it's going to include something like this: a for-cats cheat sheet. So this is, cats is not the animal. There it is. We're not really working with cats here, or animals, even though we're doing this pets thing. This is short for categorical. And so this is a package that contains a set of functions, a package within the tidyverse, which contains sets of function for working with factor variables and doing all kinds of fun stuff. Okay, so All right, give me, okay, so I have this. Okay, so where am I? Okay. So I have, so this is actually pretty key right at the top here. Let me zoom in on it. So this is what we've done so far is we have an integer vector, which is stored where the integers correspond to levels of a factor. And what's displayed are the different occurrences of the levels with an integer representation for them. So this is the mental model that you need to have in mind when you're working with factors. And then this cheat sheet is just a bunch of stuff that you can do with factors, and we'll get into some of it. Okay. Before we do that, one little demonstration. So if I have, we'll call this a yes-no vector. Okay, so if I have yes, oops, that might have been bad. Okay, and then I will specify the levels directly. No, yes. Okay, so this seems to have some sort of Bernoulli type representation, 0, 1, yes, no. But one thing to keep in mind to stay sharp with this is that when I look at the levels, it's not going to do 0, 1. It's going to do, oops, I need to actually enter it. Huh? Oh, silly me. I need to actually do the character vector. It's going to, oh my gosh, I am being so sloppy. Okay. So it's going to display the levels yes, no, but the actual integer representation is going to be 2, 1 and not 1, 0. So you could do as dot integer yn minus 1, and then you can get the binary representation. One thing that courses may try to trick you with is if you specify the levels and you change the ordering of them, then suddenly this as dot integer minus 1 switches it up. Now the zeros correspond to the yeses and the 1 correspond to the nos. So this is something to keep in mind for future reference. Okay, back to pets. Okay, so I'm going to create a more complicated pets vector. Okay. X equals C turtle. We're going to do 5 dog responses. In practice, you would never get, it would be very unlikely to get them all in order like this if this actually corresponds to random sampling, but here we are. Rep bird and okay, so we have favorite pets. Options are turtle, dog, cat, bird, snake. Okay, so some things to keep in mind. Turtle only occurs once. It's the first value observed. Cat is the most with 10, occurs in the middle here. Yeah, okay, so pets. Okay, so we can see we have levels, which are now listed in alphanumeric order, which itself is not a trivial exercise because some programming languages may have different ways of defining the alphanumeric order. Here it's pretty easy to see how it would work, but you may run into a case where different programming languages order them differently. So anyways, alphanumeric in order in R for the levels. We get the display here, that we would think we would get. Turtle followed by 5 dogs, followed by 10 cats, 3 birds, and 2 snakes. Factor with 5 levels, bird, cat, dog, so forth. 5, 3, 3, 3, 2, 1. That's right, because snake is 4th in alphanumeric order. The preview doesn't display it. Okay. So if I go to the cheat sheet, so I could do something like this, which will reorder levels by order in which they appear in the data, for one. Okay, so let's try it. In order. Look at the levels. It's by the order that they appear. Turtle, dog, cat, bird, snake. It's interesting. Let's see what else we got. Reorder levels by the frequency in which they appear in the data. Highest frequency first. Okay, cool. Let's try that one out. Infrequent. Okay, so cat was 10, dog 5, bird 3, snake 2, turtle 1. Nice. Okay, so this seems very, very, very pedantic. But let's demonstrate where it becomes useful. Okay, so I have pets. It has an alphanumeric order. I could put it in order listed or in this frequency order. Okay. So let's create a data frame, rather a tibble. Oops. Okay. Notice that when I call this, it displays in this tibble format, even though it's just one single column vector. Okay, so now if I were to do, say, pets df, and then do ggplot, and create a simple bar graph just to display the occurrences of each one of these answers for the question, what's your favorite pet? Then I would get this with the default. Oops, what happened? Oh yeah. Oh man. I'm going way too fast. Jeez. Okay, so I get this bar plot, and my head is covering it up. Okay, I'll just put my head over here. Yeah, it's out of the way. Okay, so I get my bar plot, and it's based on the ordering, the alphanumeric ordering of the levels. However, I think we could agree that it would be more visually appealing if I replaced pets with an ordering that lists them in order of frequency. And now I can have an easier time at comparing the relative order of things. Now, we may not like these axes the way that they are. It could be more, I think some people would argue that it makes more sense to flip the coordinate axes and maybe remove some of the chart junk on this and get something like this. And of course we could labs y equals something like that maybe. Oops, wait. Oh, that's right, because it flipped the order. There we go. Looks a little bit better. Okay, and then we could just play with this, make this graphic a little bit, more and more, just better and better as we go. Okay, so, right, so anyways, but the key here is that we can, changing around how these levels are ordered is useful for the visual presentation of this information here. This allows for an easier comparison or a more easy on the eyes comparison than what this would do, right? It's a little bit nicer. Okay. Okay, so let's continue on here. Okay, so let's pull pets again. Okay, another thing that I think comes up quite a bit is wanting to change around the levels, recode them, the level names themselves, and the combining of levels together. Okay, so we could do change the value. Okay, recode, manually change levels. That's nice. And collapse. So this would be something like we want to combine levels together. Okay. So let's try it out. Recode. Pets. We'll say puppy. Note the syntax. It's rather annoying that one is in quotes and one is not. The new name is not in quotes. The existing name is. Okay. So here we change dog to puppy and cat to kitten, and you can see it displayed here. Pretty simple. FCT collapse. So let's do pets, and let's create a new variable, call it other. And we will say bird, snake, and turtle. Cool. Okay, so this is actually quite relevant, I think, in this example, because oops, sorry, I wanted to move my. Oh, I hope I didn't mess up my display. Okay. So when we first introduced this pets vector, we said that it corresponded to like a survey where it was, what's your favorite animal, cat or dog? And then as we got into more complicated examples to demonstrate that these in order infrequent functions, some of the things that you can do in for cats, we shifted to include more values, turtle, bird, snake. Now, I don't think necessarily that would correspond to an interesting survey. What's your favorite pet? Cat, dog, turtle, snake, bird. Where's hamster? Or rabbit or something like that. Why? Where's mouse? Where are some of these, or frog? Where are some of these other animals that you would see? So I do think here you could ask, what's your favorite pet? And then those are the answers that you would get. Or it could correspond to something like, what's your favorite pet, cat, dog, or other? And so here, this is a coding that lumps this collapse function, took the respondent's answers and lumped it into other, which may be useful in some sort of analysis. This is something that I've actually done in practice too, looking at investigating discrimination in some context, maybe like racial discrimination in some context, and you could look at the races individually, or you could come up with more high level, broad speaking categories. I don't want to get too into that because that's its own thing, and that was a demonstration for a different day. But I will say that depending on how things are defined and the variables that you use, you can get completely different answers for whether or not something like a discrimination was observed. So the takeaway message there is that you have to be very careful statistically, and you have to be very transparent in all stages of the analysis when you're investigating questions, especially when they're of a sensitive nature. So here you can see kind of the power of for cats and its ability to manipulate factor variables. I think factor variables, for me, I encounter them, of course, very frequently as a statistician, but most of the time I'm given data sets that are, I would describe as fairly nice on the factor level side. Maybe there's some misspellings that you have to find and correct for that. But I encounter these things infrequent enough where they're extremely annoying, these like recoding and collapse. And so that this is an absolute game changer in time savings, these particular ones, recode and collapse. There's also some really interesting ones. I mean, and this is deep, right? Like there is, if I start typing in FCT, there's all kinds of functions that we can do. Let's pick one of them, actually. I saw one lump. Okay, first let's see what that does. Oh, there's a few lumps levels that appear. Oh, that's cool. Lump min. Okay. So let's see. Actually, let's read the documentation. Oh, just get this right here. Min. Okay. Other level. It's default that capital value. Okay. So, anyways, I could do pets. And I could say min equals 3. And I will say the other level equals other. Okay, so so here's pets again. So turtle, dog. Actually, let's go back to our image. That was nice. Here's pets, back to form here with a slight reorder. Okay, so what I'm gonna do is this. And what did it do? Bird, cat, dog. So bird appears 3 times. So this min is less than. It's a strict less than here. Okay, so then things with 2 or 1 occurrences got lumped into other. So turtle and snake. And the other ones are kept. Pretty cool. Maybe I haven't run into this in practice, but that's pretty interesting. Okay, so let's see here. Oh, that's cool. Cool. Count entries in a factor. Cool. That just displays right out. Okay, so anyways, there's a lot of stuff in here. The ones that I have encountered in the most are recode and collapse, and this thing I can see is extraordinarily useful, and there's a bunch of stuff in forecats. Okay, so this is just kind of a nice summary of factors, and here is a useful cheat sheet that you should reference. The key component here, or the main takeaway of factors, is just what's displayed in this top left corner, where keep in mind that a factor is an integer vector, but a very specific integer vector that when you call is.integer will return false because and another thing, it doesn't want you doing actual data manipulation to the information in the factor vector. So like, a typical integer vector, you could take all the elements and add 1 to them. If you do that with a factor, that like destroys a key structure because the integers represent an encoding to a specific level, which is some categorical information, like a character, string, displaying something that is useful. In this case, they're corresponding to name or types of pets. Okay. So we have an integer vector under the hood. What's displayed is the levels themselves. And there's a representation of these levels in integer form. All right, I'm rambling and repeating. So, okay, this is another demonstration in factors. Thank you for watching the video. Take care, and I will see you next time. All right, bye.